Hey everyone, welcome back to my channel, where we dive into solving some of the toughest problems on LeetCode. Today, we're going to tackle a medium-level problem. Delete the middle node of a linked list. I'm super excited to share my solution with you. So let's get started. The problem asks us to delete the middle node of a linked list now. This might seem straightforward, but there's a catch. We can only traverse the linked list in one direction, which means we can't just find the middle node and delete it. We need to come up with a clever solution to solve this problem. So, let's talk about the intuition behind this solution. Imagine you're on a train, and you want to find the middle car. One way to do this is to have two people, one who moves really fast and another who moves at a normal pace. When the fast person reaches the end of the train, the slow person will be at the middle car. This is basically the slow and fast pointer technique, which we'll use to find the middle node in the linked list. Now, let's walk through the solution. We'll start by initializing two pointers, slow and fast, both pointing to the head of the list. We'll also create a previous slow pointer to keep track of the node before the middle node. Then, we'll move the fast pointer 2 steps at a time, and the slow pointer 1 step at a time, until the fast pointer reaches the end or the second last node of the list. Once we've found the middle node, we'll remove it from the list by updating the next pointer of the previous slow node. Let's take a look at the code. We start by handling the edge cases, where the list is empty or only has one node. Then, we initialize the slow and fast pointers, as well as the previous slow pointer. The key part of the code is the while loop, where we move the fast pointer 2 steps at a time, and the slow pointer 1 step at a time. We also update the previous slow pointer to keep track of the node before the slow pointer. Once the loop ends, we remove the middle node from the list by updating the next pointer of the previous slow node. We also handle the case where the middle node is the second node, or the last node in the list. Now, let's talk about the time and space complexity of this solution. The time complexity is O(n), where n is the number of nodes in the linked list, because we traverse the list once to find the middle node. The space complexity is O(1), because we only use a constant amount of space to store the slow, fast, and previous slow pointers, regardless of the size of the input linked list. And that's it, guys. That's my solution to the delete the middle node of a linked list problem. I hope you found this explanation helpful and easy to understand. If you have any questions or you'd like to share your own approach, please leave a comment below. Don't forget to like the video, subscribe, and comment your approach below.